Cool. Can everyone see my screen?
Yeah.
Yes.
Yep.
All right. Let me just. And you can see when the slides change.
Yes.
Okay, cool. Awesome. Welcome, everyone. This is also my first Android Dev Hangout. I've been meaning to join some of them in the past, but it's never worked out. So I'm excited to finally see how it works. And thank you to Android Dev Hangout and Madonna and Matt for letting me talk here this morning. Really excited to get going. So I got a lot to get through. So if you have questions, feel free to post them in the chat as I'm going, or save them to the end. Have some time to discuss them there. So before I get started, I'll do my own introduction. I've been doing Android for just over 7 years. Most of that was at Square. I worked on I spent a lot of time working on a foundation team, helping introduce Kotlin, coroutines, and now Compose. I worked on some of our architectural libraries, like Workflow, and I also spent some time on our design systems team, working on building our new design system in Compose. So then a few months ago, I joined Google to work on Compose directly. That's been really fun. And you might see me in the Compose channels on the Kotlin Slack. I moderate there, and I try to help out with stuff whenever I can. So today I'm going to give you a brief a brief introduction to what Workflow is, what Jetpack Compose is. I'm going to briefly discuss how Square came to the decision to start adopting Compose and our strategy for doing so. I'm going to talk about how we actually built Compose integration into Workflow. That's hopefully what you're all actually here for. I'm going to talk a little bit about some of the things we learned while we were doing that, and some of the things you might run into if you end up doing a similar project. And lastly, I'll look at how the adoption is actually going at Square. So let's get started. This talk is about something called Workflow. So what is that, and why talk about it? It's a very generic name, admittedly, for a library that started as a pattern about 4 years ago, when we realized that thinking about navigation as a centrally managed stack wasn't really working anymore for us, and we needed something more flexible. So why should you care? There's only a few companies outside of Square using Workflow, so it's pretty obscure. But what I'm hoping you take away from this talk doesn't actually have anything to do with this particular architecture necessarily. If you've worked in a code base that's been around long enough, you've probably seen it evolve its own idioms and shapes and patterns that work well for what it needs to do. So whenever you do start to explore adopting Compose, if you haven't already, you might run into some of the issues that we did. So I hope this talk acts as a bit of a case study that you might be able to refer to when you do that same kind of work. That said, there are some specific things about this library Workflow that made this project pretty straightforward, and something that I was just really excited to get started on. And I think this project really kind of solidified our confidence that we made some good design decisions with Workflow early on. So it helps to know a little bit what Workflow is, but this isn't a purely Workflow talk. So I'm going to try to go over this stuff pretty quick, and I'll skip some details. But if you want to learn more, we have multiple talks about Workflow, and we've written blog posts, and there's docs online. So I'll post some links at the end of the talk. So there's kind of two sides to Workflow. It lets you write your business logic in a modular, reusable way, flow coupling, and it's very friendly to dependency injection. It also provides wiring for all the bits you need to build the view layer of your app. So let's talk about the non-view stuff first. Workflow is basically React for business logic and navigation. I think it's roughly an implementation of MVI, but I don't like the MV acronym, so I'll stay away from that from now on. So you write business logic as isolated, decoupled components called workflows that generate view models that we call renderings. Renderings are just value types, typically, that tell the UI what to display at a particular snapshot in time. And workflows themselves don't know anything about pixels or input or graphics or anything like that. A workflow can optionally accept some input data called props and optionally have its own private state. It can receive events from the UI through its renderings, and workflows will regenerate the renderings when their input data or internal state changes, just like Compose or React or any of these other things. So workflows are typically classes, and so they can be easily dependency injected either by hand or using whatever library you prefer. Square uses Dagger or Dagger 2. So workflows form a tree. A workflow can ask other workflows for their renderings and incorporate them into its own. And a rendering can contain other renderings. So props flow down and renderings flow up. And so that's how you write business logic. We still need to turn those renderings into actual views. And the workflow library helps with that. A rendering is just a model, just a view model, lowercase vm, that holds some data. So you tell the workflow runtime how to create a view for each rendering type you need to show and how to update that view every time there's a new rendering. The logic that does this is called, in the workflow library, a Viewfactory. It's really just a presenter. It takes a model and updates a view and wires it all up. So we call them view factories because they also are responsible for actually instantiating the view. But if you're not familiar with workflow concepts, you can really just think of them as presenters. But I'll call them view factories for the rest of the talk. So once you've set this up, then any part of your app can ask the runtime to show any rendering value anywhere on the screen, and in basically a single line of code. So remember I said workflows form a tree, so do view factories. A view factory for a composite rendering that contains other renderings can, for example, like provide a layout that does some arranging, and then just ask the runtime to display views for its child renderings in the right spots. Individual view factories are decoupled from each other. They don't know anything about other view factories. In fact, it's pretty common for composite rendering types to not even know what their child rendering types are and just use the type any. So I'll get how this actually looks in a little bit. But this design has a few advantages. Like I mentioned, it's really friendly for injection. So view factories and workflows are both typically classes, so you can really inject them both if you need to. Typically, view factories don't have a lot of dependencies that they need injected, but sometimes they do. And workflows are really easy to inject, including you can inject your child workflows. So that's really a nice pattern. They're reusable. You can take both the business logic, the workflow part of a component, and its UI or its view factory, and you can reuse them in different places in the same app. Which is one of the main reasons that we ended up building something ourselves new, was because we were building more and more components and entire flows and features that needed to be available in multiple places in the app through multiple paths. And that was getting really hard to do with a single kind of stack-based navigation. They're really testable. A workflow test basically just needs to provide some input data and assert on the rendering that gets spat out. View factories only need to be provided their model, the rendering data, and they don't have any dependencies on any other views or even really any other parts of the runtime. They're really modularizable. That's a lot of syllables. So workflow code tends to be have very low coupling. Workflows typically only know about the immediate children that they care about, and you can use all the regular patterns you use from object-oriented programming, like interfaces and stuff, to keep those abstractions nice and separated. So it's really easy to organize workflows into fine-grained modules, Gradle modules, which can be really good for your build tooling and CI and all that stuff, and however you want to organize that. Square has a pretty well-established pattern for doing that sort of thing, and workflows work really well with that. And another cool feature that I'm going to be focusing on in this talk is that it's really easy to, once you've written the business logic, you can customize and kind of swap out the implementation of the actual view very easily, even at runtime with like feature flags or something. So you can write multiple view factories for a single piece of business logic, and maybe one in views and one in compose, and then decide which one to use at runtime, or different consumers can potentially choose their own, whichever one they want to use. Okay, so that's really quick introduction to workflow. So let's talk about Compose. I think if you're here, well, you probably know what Compose is. It kind of looks like this. I just stole this from the official docs. So I'm going to assume that you kind of know at least the basics of Compose. It might help to know about some more potentially more advanced things like Android Compose integration stuff, but I'm going to try to explain that as I go, and stuff like composition locals and all that stuff. But yeah, there's lots of tutorials and introductory talks and stuff out there that's really good. So if you want to learn more, there's lots of other places to go read about that. I will say that I'm going to say compose in this talk a lot and actually mean compose UI. So I apologize for that in advance. For this talk, if you hear compose, just think compose UI. So that's all I'm going to say there. So let's talk about how Square decided to adopt compose. So Square's adoption story really kind of has 3 prongs. The first 2 are infrastructure, and they're independent, but they're both needed for the 3rd prong. So the infrastructure prongs are workflow integration. So we needed to, a lot of our screens and code is written as workflows. So we needed to, and Viewfactories. So we needed to provide APIs to make it easy to use Compose from that environment. And then the second prong is the design system. So Square doesn't use Material. We have our own design system and or multiple design systems. And so those have their own styles and components. So we needed to write those as composables so that we can use them from Compose. Now, you could, of course, use Android views from Compose, but it's just, it's cleaner. We were actually building a new design system anyway. So we were like, well, we might as well just build in Compose. So those are both workflow and the design system are built, are live in their own repos. And they're consumed as Maven dependencies by the main kind of mega repo. So, but because they're kind of separated out, it makes it really easy to experiment with stuff like Compose and use like alpha versions of tooling and play around with different things like that and write a whole bunch of sample apps without having to deal with like large build times or risking breaking the builds or anything else for our production apps. So that was a nice feature of kind of how we decided to organize the code that came in handy here. And then the third prong is building features, of course. So the best Compose infrastructure is pointless if there's no features actually using it. So once the design system is ready and the workflow integration is ready, we can actually start building features and building UIs in our apps with Compose. So here's a really quick, rough timeline of kind of how this went, kind of starting from when Compose was announced in 2019. I'm not going to go over this in detail. If you want to take a look at this, come back to the recording later. I'll share the slides. But basically, we kind of did the workflow stuff first, and then when Compose announced the release timeline, we decided to try it with the design system, and that work is well, I'll talk about that at the end. So most of this talk is going to focus on the workflow integration part, as the title kind of hinted. So let's talk about that. Time to look at some actual code. So I'm going to talk about some new workflow APIs that make working with Compose pretty seamless and how they work. And I hope I got enough time to actually talk about everything. Okay, so let's start with the most basic and common thing a workflow developer typically does. You've got a rendering type, which again is probably just like a data class, and you need to show a view for it. So there's 2 ways to do this. The rendering type itself can implement a special interface that tells the runtime how to provide a view, or you can write a separate kind of external view factory for that rendering type and register it with a runtime explicitly. So let's start with the first option. So this is about the simplest rendering you can write. Single property. Let's give it the ability to draw itself. So we need to implement this interface called Android View Rendering, which knows about the rendering type. It's kind of like a self type. And it has a single property that returns the view factory. So we'll implement that. We're going to use something called Layout Runner to create a view factory that inflates an XML layout and delegates the actual wiring to something called a layout runner. So we've got this new layout runner, which implements a layout runner interface. And it takes in the view. So there's one layout runner per view instance. And anytime the rendering, there's a new rendering, a new view model, new data, including at initialization time, this show rendering method gets called. So if we want to implement that, we're just going to pull a text view out of our XML layout and set the text property to the name from the rendering. And that's it. So we've got these 2 pieces, the data class, the rendering type itself, which implements Android view rendering, and the layout runner that does the wiring. So that fits on a slide pretty nicely. It's not a ton of code. I'm not going to show the XML just because you can imagine it's probably pretty simple. But there's still some boilerplate here. So, and and we can do better in Compose. So let's see what that looks like. So we've got our data class, but this time we implement Compose rendering instead of Android View rendering. And note the lack of type parameter. This interface also has a single member. It's a composable method called content. A lot of the time, content is kind of a common term in Compose. And it's a composable function, so we can emit UI. So we're just going to emit a text with a name, and that's it. Much shorter. And note that we also don't take the rendering specifically, so we can just refer directly to the properties on the rendering, and it's just less boilerplate and really clean. So let's look at how that actually works. One thing to note is the code that I've showed kind of so far has been code that a feature developer would write, and now I'm going to show code that's actually in the workflow library. So this this Compose rendering interface implements Android View rendering. And so it has to provide this Viewfactory property. We use nothing as a type parameter here because Compose rendering just refers, or basically it like closes over the data class itself, and so it can refer directly to its parameters. We don't actually care what type of rendering it is. So just some fun Kotlin type gymnastics here. So we have to provide a Viewfactory, and we define this abstract content function that we're going to override to actually provide the content. So what does that Viewfactory look like? We're going to create an instance of something called Compose Viewfactory. This is where a lot of the cool Compose stuff happens, and I'm going to talk more in detail about this in a little bit, but I'm just going to show how it's used for now. So it also has one member that we need to implement. It's also called content. It's also a composable function, but this one takes the rendering as well. So we're just going to call the content function on the rendering. So it's maybe a little bit confusing because there's a lot of kind of duplicate terms there, but it's hopefully we'll see a little bit how this works later on. So as a workflow developer, though, this is all you have to do. Just write this name rendering, implements Compose rendering, and write a content function. Okay, so we've seen something called Compose rendering. We've seen a peek at something called Compose Viewfactory. I'm going to keep a little list going here of things we've seen. But let's get a little more complicated and say we want to show some more information about a person. So remember this diagram? Viewfactories can form a tree, and they can show Viewfactories for other renderings. So let's see how that works. I'll skip the view comparison from now on, just because in the interest of time. But if you are familiar with workflow terms, this is going to be workflow view stub, the Compose analog of that. So let's rename name rendering to person rendering and add some extra details. We don't actually know or care what those details are. They could be an address or some social media info or a phone number. Everyone may have different details stored on them. This is a bit of a contrived example, but it's fairly simple. So in a real app, this might be a CL class or interface, but there's also times when you actually do want to use any as a rendering type. So we're going to just use any to keep it simple. So let's actually show some pixels here. We're going to implement Compose rendering. We're going to provide this content function, emit the name, but we also want to show the details. So we're going to wrap everything in a column and get the details out there somehow. To do that, we're going to use something called workflow rendering. This is a composable function that's provided by the workflow library, and it shows a workflow rendering. It takes the rendering value to display and an optional modifier, which we use here to make sure it fills up the rest of the column. And just like any good composable should take a modifier. And it takes, we've seen this a couple of times now, this view environment thing. I haven't talked about it yet, but I'm going to go over it really quickly here. It's not a Compose specific thing, but it is related to composition locals in Compose. So it's basically just workflows version of composition locals. Like composition locals, parents can add things to it and change things in it and then pass it down to their children. And it's just basically a map of typed keys to values. So you can store arbitrary stuff in there. We use it, for example, to indicate to children, like if they're in an overview screen or a detail screen, among other things. So yeah, the reason that workflow has its own type for this is because we needed something for Android views as well. So the view environment is always passed down through the view factories, whether they're compose based or view based or something else. One question you might have is why not just put the view environment in a composition local then, since it's kind of the same shape and kind of has the same semantics. Be less boilerplate, but we decided to not do that for a few reasons. One of them being that it serves as a good hint that functions like workflow rendering should only be called from view factories in kind of like this workflow kind of context. You wouldn't just like pull this workflow rendering function out and use it in an app that's not using workflow. That wouldn't make any sense. So another advantage is that if you've been writing workflows with Android views, you have to pass this through explicitly anyway. So it kind of helps hopefully ground some of these new APIs for developers coming from the view side and like, okay, I know this concept, so I can kind of guess how this fits into the whole system. But anyway, let's get back to Compose and see how this workflow rendering function actually works. This is the signature. It takes the rendering value. So we don't really have any restrictions on this other than it must be something the runtime knows how to show. We can't validate that at compile time though. So we just take any, and then we take a view environment and this optional modifier. So to create a view or a composable, we need a view factory. And here's something that we actually use a view environment for. So we can ask the view environment to give us a view factory for any given rendering value. So we do that here. We say get factory for rendering, which gives us a view factory. But a view factory is something, as we'll see in a little bit, that only knows about Android views. And we're writing Compose code here. So we need to somehow make that something we can call from Compose. So we have this function, this helper function called as compose view factory, which just remember that compose view factory class we looked at a little bit earlier. It just takes whatever view factory we get and turns it into one of those. It's a little bit magic maybe, but I'll talk about how that actually works in a bit because it's also kind of interesting. But for now, just remember that compose view factory type, we're getting one of those. And then remember we had this content function on there. So we just call the view factory's content function, pass in the rendering in the view environment that we currently have. Now we're showing whatever the child content is. But we still need to apply that modifier. So let's wrap the content in a box. One thing to note here is we're passing propagate min constraints as true. And this is something that you might, that I think is kind of maybe an important takeaway if you're writing kind of your own infrastructure, compose infrastructure stuff here, because box by default will let its content be whatever size it wants to, or at least as small as it wants to be. So if the box itself has a minimum size constraint, it will measure itself to be that size, but then it'll align its content within itself. But in this case, if the caller of this workflow rendering is giving us a minimum size constraint, then they probably intend for that constraint to apply to the actual child view factory content. So, if they're saying, I want you to like fill parent or fill max size, for example, they want the content to fill that max size. So we need to pass through the min constraints to the actual content. Box is a super flexible component, and you can use it as kind of like a frame layout. In this case, we're only really using it just to make sure that we can apply the modifier to the content. And so it's an implementation detail, and we don't want to actually like do any aligning or anything like that. So we need to pass propagate min constraints as true. And there's good KDocs on more details about how that works. So we've got a pretty good start here, but we're not quite done yet. Remember this slide? So we've kind of got an overview detail example here. Can you think of any other way that you would implement this on Android? Well, fragments is one of them. These fragments. Who doesn't love fragments? They're so simple and easy to use. So one of the reasons that Square started building its own architecture libraries years ago was because we didn't want to deal with fragments. And back at that time, they were a lot buggier than they are now. And we didn't have to support libraries. But even today, views and composables have a much simpler lifecycle than fragments do. They're attached or composed, and then they're detached or not composed. Very simple. So most of the time, that's good enough for what we need to do, and it's a lot simpler to reason about. So that makes life easier on future developers. But unfortunately, as when you're building kind of infrastructure like workflow is, you can't just kind of pretend that things are that simple. You have to deal with the reality that a lot of Android code still expects lifecycle contracts and different hooks like that we still have to satisfy. So Compose, for example, relies on the Android X architecture component lifecycle hooks to initialize itself and clean up after itself. So to make sure that all works correctly, we need to pass all that stuff through and wire it all through. So we need to somehow talk lifecycles. So there's the lifecycle owner interface in the Android X libraries that we can use. There's a composition local called local lifecycle owner that we can use to provide any lifecycle owner we want to all of our children composables, and also any Android views that they happen to use inside of them. Lifecycle owner is a pretty simple interface, just provides a lifecycle. So we create a special implementation of lifecycle owner that does two things. It looks at the current lifecycle owner. So this remember child lifecycle owner function is a composable function. It reads the local lifecycle owner and mirrors that lifecycle, that state. The lifecycle it returns mirrors that state. And then the one other thing it does is when it's removed from the composition, then it moves its state to destroyed. I'm not going to show the code here, but it's not actually that complex. It just matches the parent events and then uses a disposable effect to set itself to destroyed. Again, if you want to look at how this works, I'll link the repo at the end of the talk. So this is maybe a bit weird because in general, a composable being removed from a composition doesn't trigger lifecycle events, or that'd be like a crazy amount of boilerplate. So this is a bit of a special case though, because workflow renderings or view factories, kind of like fragments, they're more than simple composables. They're more kind of like navigation primitives. So when you decide to stop showing a workflow rendering or a child view factory, that's more like almost like a navigation event. Or if you decide to show a different rendering and you have to get rid of the old view factory and create a new one to show the new rendering. But we're not doing that yet, because if you've read this carefully, you might see a bug. So we remember the view factory by driving it kind of from the rendering type, which we're getting in as a parameter. But what happens if that changes? So the workflow rendering function can be called again or recompose because the caller changes something and passes in a new rendering at any time and give us a different rendering type. But because we've remembered the view factory based on the rendering, that same view factory will keep getting remembered. So when we try to show a different rendering type that's maybe incompatible, we might crash or something like that. So you might think, well, let's just pass the rendering as a key to remember. And that could work for some cases, but we actually want a little bit different behavior. So let's try that though. So we're going to take the rendering class and use that as, we're going to call it a compatibility key. And then we're going to, I thought I deleted the slide. Just pretend that it says rendering class. There's a little bit more workflow stuff going on here, but it's not really important to this talk. So we're going to take the rendering class and pass it as a key to remember. And now we'll get a different view factory every time the rendering type changes. But so that's good. We won't crash anymore because of the view factory being the wrong type. But we still have the life cycle from the original view factory is still going on. So it wouldn't when we change the view factory type, we want to set the old life cycle as destroyed and start a new one. So one easy way to do this is, well, we just really need to apply that remembering key sort of concept. And we need to apply that to the entire rest of the function, not just the view factory that's remembered. So Compose gives us a nice function for this called key. It's a composable function. It takes arbitrary values in, and when those keys change, it will completely tear down its content. Effects will be disposed, state will be destroyed, and recreate it from scratch. In this case, that will cause us to initialize a new Viewfactory and also tear down and create a new lifecycle owner. So this is the entirety of the workflow rendering function. There's a lot going on here, and it took a while to get it down to the shape, but it's got some nice features. So that I think if you're also doing this sort of project, hopefully you'll be able to take advantage of as well. So for example, remember child lifecycle owner it only knows about like it enters the composition and then it uses a disposable effect so that it leaves a composition. And that's all it does. So the actual implementation is pretty simple. And it's really easy to test. It's just easier to read and it's easier to reason about. And it doesn't have to like know about really the rest of the behavior of this function. And then on the other side of that, this key function that Compose gives us, it makes it super clear how the rendering compatibility key affects the rest of the stuff in this function. And it's not just, and part of the reason that it does that is because it shows that scoping kind of as like actual like lexical scope in the source code. It's indented, and it's like kind of some of the nice things about structured concurrency, how, you know, if you have a coroutine scope, you can see everything that's in that scope and what the lifetimes of those things are just by looking at the source code. You kind of have the same feature here. So I think these kind of generalize as one of the really nice features of declarative code, which is that even though this function has relatively complex behavior and contracts, every line of the function, if you ignore the closing braces, is load bearing and really significant. There's almost no boilerplate here. Every line is important and does a really important job. So the Android View version of this, for example, is very complex in multiple files and way more lines of code. And even like when I was working on it and trying to get all the lifecycle stuff wired up, it's very difficult to kind of keep in your head because again, like the view lifecycle is different. You've got object lifetimes to deal with, plus attached lifetimes, and so the actual code in the repo for this function is a little bit longer because it has tons of comments. But that's also, I think, one of the nice features about declarative code like Compose is that it's easy to write really thorough and helpful comments that explain the why and kind of the implications and stuff that isn't necessarily obvious from the code, because every line kind of has its it's kind of self-contained in a way, right? Like it expresses something important, and so you can document stuff about that by just leaving a comment on that line, and you don't have to refer to other parts of the function as much when you're documenting it. So I think it makes documenting easier as well. So that's workflow rendering. We still haven't seen Compose Viewfactory, so let's take a look at that. So this is how we show composables inside Android views. So let's look at what Viewfactory actually is. It is an interface that has a single function called build view. Like any factory, its job is to return a thing. So we're going to build an Android view here. It takes the rendering value, and it doesn't take the rendering type because it also needs to initialize the view with the initial rendering value. So then it needs a view environment and an Android context, because you can't instantiate or inflate views without a context. And it might get the container view group. So these last two parameters probably look familiar from Android APIs like Layout Inflator, and they kind of have the same idea. Compose Viewfactory is just an implementation of this interface. It's an abstract class because we want to override build view, but we don't want any of our subclasses to be able to override build view. So we make it final. It creates a Compose view. So this is really, Compose view is provided by Compose UI, and it is an Android view that can show composable content. And this basically does most of the work, complicated work for us, which wasn't always the case, but I'll talk about that at the end. So Compose view, if you haven't used it before, has really only one function that we really care about, called set content, which takes a composable lambda usually, and you can just emit UI from there. So where do we get our content from? If you remember earlier when we talked about this, we had this abstract content function That's a composable function, and it takes the rendering and view environment. We just call that. So this, I mean, if you've done anything with Compose, you probably use Compose View or Abstract Compose View. It's really the only way to get into Compose on Android. We need one more thing, though. It's not just enough to pass the initial rendering to the content. We also need to update that every time we get new rendering data. So the workflow library defines an extension on views called bind show rendering. It basically just does some tag bookkeeping. So you set up a callback that will be invoked whenever the view is asked to show a new rendering. So if you want to see how that works, you can look at the repo. But one important detail about this is that it will invoke that callback immediately before it returns to initialize the view, but then also anytime in the future that the rendering value changes. So we just put that set content call in there, and then whenever we get a new rendering, we now pass that rendering to the content function. And you can call set content on a compose view multiple times, and it's fine. And it will actually keep all the composable state and everything too. So this is a really, really concise way to do this. And that's it. That's how Compose Viewfactory works. It's really not that complicated. Really, all it does is just set up some update logic. Everything complicated is done by the Compose view itself. And because this is a Viewfactory, no other code that knows about Viewfactories needs to know Compose exists. They ask for a view. We create a view, give it a view, and all the Compose stuff is kind of hidden as implementation details. So remember that Compose rendering interface we looked at earlier? It had a subclass of Compose Viewfactory, and here's that code. And so just to kind of like tie things together, this is where we're calling that content function from. So we've seen how to make renderings provide their own Viewfactories by implementing Compose rendering. But we also said there was another way to do this. And we can create a separate Viewfactory class. So now the person rendering class is just a data class, doesn't do anything else. And we've created a separate person Viewfactory that implements Compose Viewfactory itself. And then it has this content function. And now it takes the rendering as a parameter. So this can be useful if you want to like have different Viewfactories with the same rendering and swap them out, or if you want to like separate your Viewfactories and your renderings, put them in different modules. It's another option you have. In fact, we've made it really easy for you by giving a nice little convenience function, Compose Viewfactory, that just returns an instance of Compose Viewfactory. But all you really need to write to build one of these is a function. So this is just a simpler way to do that. And that's a composable function in there that gets the rendering. So I don't think it could really be simpler than that. There's like no boilerplate there at all. So that's Compose Viewfactory. We still have a little bit more to look at. So in the workflow rendering, we saw there are we never actually called that build view function that we just saw in the Viewfactory interface. So we just called this as Compose Viewfactory, and I said I'd talk about this later. So how does that work? Because Compose Viewfactory implements Viewfactory. So inheritance can only go one way. We can't. So how does this actually work? Well, let's look at the code. So the first case, if the Viewfactory is already a Compose Viewfactory, well, that's simple. We just cast it in return. And this is kind of nice, not only because it's very easy it's just very short, quick implementation, but also because it means that if you've got a lot of Viewfactories that are all composables, maybe like a whole app full of composables, we don't actually have to jump out into the view world at all. Almost lost my water bottle. We can stay in Compose the entire time and don't have a lot of stuff getting in the way. So as an example, let's look at these two Viewfactories here and how they interact. So we've got two composable Viewfactories. One's just called color, and it just shows the string representation of a color, any color we pass to it. Then we've got a red Viewfactory, which spits out the word red and then shows the representation of the color red from this other Viewfactory. So we have a row, we have a text, and we have a workflow rendering. So let's now substitute the body of that workflow rendering function in here to see how this kind of looks. So this kind of is to give you an idea of what like the call stack would look like inside of the composables the first time you're kind of building all this stuff. So there's not a ton of stuff here. And again, this isn't, I kind of inlined it manually here just as an example. This doesn't actually get inlined, but just to kind of show you what's going on, we stay in the compose world and there's no interviews involved. And so it keeps things a little bit cleaner at runtime. So, okay, so that's the simple case. What if the Viewfactory isn't already a compose Viewfactory and we have to make one? Well, then we have to implement the content function. And we're going to kind of use the opposite of the compose view that we saw earlier. So compose view is a class. It's a view class that lets you go from view world to compose world. Android view is a composable that goes the other way. There's a number of parameters and default values, but the most common usage probably just passes two functions. There's a factory function that creates the view object and an update function that gets the view that we just created and updates it anytime something changes. So the factory function is only called once when the Android view is initially composed. The update function gets called anytime something changes, and also initially to initialize the view. So in the factory, we're going to create the view, and here's that build view function that we saw earlier. So we're going to pass in the rendering view environment. The context comes from the factory, so that all flows through. We don't pass in a container because we don't actually have a view group container. We're in a composable. So now we just have to make sure that that view also gets updated whenever the content is, whenever we get a new rendering value. So remember that bind show rendering I talked about a little bit earlier? It's just hooks up this callback. So here's call that callback. There's another extension on view called show rendering, which reads the tag and whatever the bind show rendering set up, gets that callback out and just calls it. So this will get called anytime the content function recomposes with a new rendering value. We do a little bit of validation here to make sure that we actually install a bind show rendering correctly so that implementations are validated to do the right setup work. And then that's it. That's all you have to do. We've now taken a view-based thing and turned it into something we can just call as a composable function. So again, not a ton of code actually. And there's Android View is doing quite a bit of work. And it used to not do as much work, and we had to do some more boilerplate ourselves. And I'll talk about that in a little bit. So those are kind of like the four main pieces. One thing to know, as Compose Viewfactory, that's not public API. The other three things here are all public API that Workflow provides. As Compose Viewfactory is just this private function that just works under the hood. And so with those three bits of public API, you don't have to, it's really easy to write large apps that use both view-based and compose-based Viewfactories and delegate to each other. And if you're delegating to another Viewfactory, you don't have to care whether it uses views or compose. If you just kind of pick the factory you need based on the code you want to write. So if you want to write a compose-based Viewfactory, you use compose Viewfactory or compose rendering. And then if you want to call another Viewfactory, use the workflow rendering function. And if you're on the view side, then use the view versions of those things. And they work together seamlessly in both. So this makes incrementally adopting Compose very easy in an app that's built with workflows. You only need to convert a single factory to Compose at a time, and there's no dependencies across Viewfactories. Here's kind of an example of what that could look like. You can start at the bottom and start converting your Viewfactories from the bottom and go up, or you can start at the root and go down and start in the middle, whatever you want to do. So one example of this is the workflow library provides a Viewfactory for backstacks, and that's right now implemented with views. So it does transition animations and view state management. But you can use this in an app that's otherwise fully Compose and not know or care that it uses views under the hood to do stuff. They interop in both directions, again, seamlessly. So I see that we're at 42 minutes here, and I definitely was going a little bit slower than I hoped. So I'm wondering if I can still have time to talk a little bit about some of the stuff we learned. And if not, feel free to cut me off, Madonna, but I'm going to just keep going then, optimistically. So we're almost done here, but I did want to talk about this stuff because I think this is pretty important. So
yeah, please finish it up.
Okay, cool. Thank you. So the first thing that we kind of had to learn about here is something called view tree owners. They're a bit of a newer thing provided by the Android X libraries. When you use a component activity, it all this stuff all happens under the hood. But view tree owners are kind of a pattern that's basically a view-based way to do what composition locals do and pass data down. So I mentioned that there's this like local lifecycle owner composition local that you can use to pass a lifecycle down to your children. There's a whole bunch of locals provided for Android stuff like the local save state registry, the view model store owner. Those all kind of are propagated through Compose as composition locals. In views, they're done not through. There's obviously no composition locals, so they use basically they just use view tags. So the way that a view tree owner works is it's typically just a class with two static functions, a getter and a setter. When you can set the setter will just set a value with a tag on the view, and the getter will look up the view tree to find the first parent that has that tag set. So kind of has the same semantics as composition locals, but a little bit more manual. And this is nice because previously you would do this sort of thing by looking at the context, which means you were probably talking directly to your activity or your fragment. And if you wanted to, in the middle of your view tree, change one of these values, there was really no way to do that because you had to you could override the context and provide a different context all the way down, but that's kind of awkward and probably more work than you really want to do. But this little graphic behind here is from a cartoon called Happy Tree Friends, which I thought sounded kind of like view tree owners. And the cartoon is about these cute little animals that, well, let's just say that they fall on some hard times at the end of each episode. If you haven't seen it, it's just you might want to, yeah, it's an interesting show, and it's a little bit gory. But just like Happy Tree Friends, view tree owners seem cute at first, but there are some not so pretty surprises in store. So they do provide more flexibility than using activities and fragments for this stuff, but they also require a bit more work. So every time you have a new root view, like for example in a dialog or in some sort of modal, you have to make sure that you wire up all of the values that are expected to be provided as view tree owners from whatever view you're from somewhere else in your main activity or your main window. And this is something that kind of happens automatically when you use Compose, but if you're using view tree owners, you kind of have to do it yourself. So working on this project, I found quite a number of bugs in Compose. One of them was that Android view composable I talked about a little bit ago. It wasn't forwarding to view tree owners, or it wasn't forwarding the values from composition locals that had corresponding view tree owners to its view. So if you had a view inside of a composition, inside of another view, that leaf view, if it looked for the lifecycle, for example, it would find the lifecycle from the view hosting the composition. And if the composition in the middle provided its own lifecycle owner, like we did in that code earlier, that would be invisible to it. So that was actually the first bug I fixed when I joined Google, because it was just bugging me so much. But there's still some cases where we haven't been able to solve that in Compose yet. For example, if you need to forward the view model store owner, which has its own composition local and a view tree owner, but all the view model stuff lives in a separate library, and the core kind of Compose libraries that have stuff like, for example, the pop-up composable can't depend on that. So if you don't know about a view tree owner, you can't, or a composition local, you can't do anything with it. So Compose solves this nicely, because when you do this sort of thing with Compose, you just create what's called like a subcomposition, which forwards all of the composition locals. But there's no way to do that with view tree owners because they're not like it's not really like a mechanism. It's just a pattern of like setting some view tags, and there's no like automatic forwarding of view tags because it's not really, it's kind of a little bit hacky almost. So you have to think about some of these edge cases. Like if you're showing modals, for example, like the workflow library provides, it provides a backstack mechanism and also provides a way to show dialogues, and it has to wire this stuff up itself. Something to keep in mind. I didn't really talk a ton about view state restoration, but if you're building an architecture or navigation library, you have to think about this. If you're building a backstack, for example, and you push something onto the stack, you hide the previous view, show the new view. That previous view or fragment or whatever it is, all of its view state needs to be saved so that when you come back to it, it can be restored and look like it never went away. Fragments does this for you automatically. The Jetpack navigation library does this for you in most cases. Workflow does this for you, but anytime, if you're writing your own navigation library, you have to implement this all kind of basically from scratch. And it turns out it's tricky. It was tricky in the view world, even just with views. So views, like you're probably familiar, have this have two methods: on save instance state, on restore instance state, and they're a little bit complicated. They have like this kind of weird parsable API with a bunch of kind of requirements that are easy to get wrong. You have to have if your view wants to save its state, it has to have an ID, and the save and restore methods have to be called at particular points in the lifecycle of the view kind of world. And so when you're writing a navigation library, you have to make sure that you call them in the right place and that you save your own state the right way. But we don't only have to handle the view case. We also have to think about this new Android X stuff. So Android X provides something called the save state registry, which is a very different API from how views traditionally save state. Instead, you register a state provider as a callback with a key. And then to restore your state, you just ask the registry for the state you saved with that key. But those also have to be called from specific and different points in the lifecycle. So if you're supporting both of these as a navigation library, you have to have like kind of 4 different points in the lifecycle where you're doing these things. And one of the nice things about save state registry is it doesn't know about view IDs, but it does have these keys. And so keys have to be unique to a registry. They're strings, they're not integers. But how do you identify your children views versus like state registry callbacks? There's a lot of different kind of things to think about here. Compose has its own state management API based on the savable state, or based on save state registry. It's called savable state registry, which is not confusing at all. The API is very similar to the Android X, like to the save state registry one. But you probably, if you're writing Compose code, you won't actually see that. You'll just deal with remember savable, which is really nice actually. But it all uses this save state registry under the hood. So if you want to support Compose's save state, you have to support the save state registry. And save state registry, because of its lifecycle requirements, also depends on Android X lifecycle. So you can't just build save state support. You also have to wire that into your lifecycle management, and it all just gets like very complicated. And if you look at the Jetpack nav code, for example, for this, it's super complicated, and the workflow code for this is pretty complicated. And yeah, it's a lot of work to get right. And if you get it wrong, it's not necessarily that you'll see like crashes or obvious bugs. It's more like you're saving state to the wrong scope, and so that might not show up for a while. So there's a lot of tests here that we've written, yeah, it's just this was the hardest part of this work for sure. Compose view interop is another thing that right now is super nice. Most things just work. But back when I started working on this in early 2020, it was pretty incomplete, and so you had to do a lot of the wiring yourself. So, for example, here's how Compose Viewfactory looked in May of 2020. And there's a lot more code here. We had to wire up we had to know about subcompositions and other things that we had to do kind of from scratch. And we had to work around bugs and crashes that happened in different cases and stuff. And now it's just this, so it's a lot simpler. Yeah, found a lot of Compose bugs working on this project, and credit to the Compose team. They were super responsive in responding to the bugs I filed, and they fixed things pretty quick. And then the few things that weren't fixed, I managed to start fixing myself, at least when I joined. So that's actually pretty nice now. And then composition locals. I mentioned earlier, like why don't we use composition locals for view environment? It's the same if it's the same idea. Well, if you've been doing any Compose stuff for a while, you've probably heard the Compose team or someone or read that you shouldn't be using composition locals for everything. It's easy to kind of treat it as like a one size fits all. I need to pass some data down. I'm going to use a composition local for it. And we strongly advise against doing that because it creates implicit data dependencies, which are harder to test and maintain. And it's more magic and kind of makes it harder to follow data flow. So we thought we had, when we were doing this work for workflow, we thought we maybe had an exception because we kind of had the same shape. But we ultimately realized that we didn't. And we took the Compose team's advice in the end, and it made things better and just easier to read and reason about and stuff. So that all goes to say, writing a navigation library from scratch is really hard. And there's a lot of stuff that you have to think about that you've probably not thought very hard about before if you're doing Android work. Got to write a lot of tests. And again, writing tests for this stuff can be tricky too, because the cases you have to test are not your typical, maybe not your typical kind of scenarios. And this wasn't the first navigation library Square wrote either. Like we'd done flows and border and other things in the past. But even with all the stuff we learned from those, it was still, there was new stuff that we had to deal with, and it was still like tons of work. And we made lots of mistakes along the way, and lots of iterations here. So, but that said, if you're willing to kind of take on that risk and that work and put in the time, we spent a large part of 2020 kind of working on this and polishing it all up, then being able to like define everything about your app's architecture top to bottom, define your own terms and your concepts and the shapes you want to use is really, really nice. And in the long run, like it'll, you know, if you find something that works for you, can make your feature developers' lives a lot simpler. So after all that stuff, let's see how things are going over. Block, sorry. How's adoption going? So the workflow stuff, as I mentioned, was done kind of in 2020 mostly. We landed it in the summer, and just this last summer, 2021. But mostly that was just polish and landing some PRs. The work itself was mostly done by the end of last year. But we couldn't just start writing Compose code. I mentioned that Square uses their own design system, and it's not Material, which Compose ships with components for. So we had to build all of our own components for our design system, and also think about how to build the theming infrastructure that we needed to use in Compose and in a Compose-friendly way. So that was a lot of 2021. We started that project at the beginning of this year, and I joined the design system team at that point to help with that. And from what I hear, it's almost done. They're about to kind of internally ship their first alpha of this design system. And at that point, hopefully people will actually be able to start writing features with it. But we do have a number of samples I keep saying we. Square still has a number of samples internally showing all of the wiring working inside of the additional kind of proprietary boilerplate and scaffolding that the Square apps use, and showing how that it all works together and everything. And it's like there's a lot going on behind the scenes, but when you just like you sit down to write a feature and you just like write Compose Viewfactory and write some composables, it's like so clean and really nice. And I'm really excited for future devs to start using that. So that was a lot of stuff. I went way over time. And I still didn't talk about everything. We built some other APIs as well to get into the Compose runtime, into the workflow runtime from Compose, using stuff like the Compose support for coroutines came in really handy. And again, the lifecycle management stuff really made that a lot cleaner, like the simpler Compose lifecycle stuff, like effect handlers and stuff like that. So I could talk about this stuff all day, probably all week. But one thing I want to leave you with is that like Compose is well known as kind of the poster child for cool demos. A lot of good animation GIFs come out of this. I made a cool one last night myself when I was supposed to be finishing these slides. And that's, I mean, it is really good for that. Like you can make really cool looking things and hopefully like delight your users a lot with how the things you can build with this. But there's more to Compose than just writing features that your users see. There's some really cool API features in Compose and just the way that Compose was designed that make it really interesting for infrastructure devs. And if you're working on a larger app and you spend all your time on infrastructure, that can maybe, get a bit dry at times, but there's some really cool stuff that you can take advantage of with Compose on that side of things as well. So I hope that I've been able to kind of show some of maybe the less shiny parts of how you can use Compose, but make not only your users, but also your coworkers really excited by this stuff. So finally, that's it. Thanks for coming. Thanks for listening. There was a lot there. So here's some links. I've got my Twitter. I've got this Kotlin Slack. If you're doing Compose and you're on the Kotlin Slack, you're missing out. The Square Workflow Library, the docs on Compose. And I actually wrote a blog about this in August, some of this stuff with a little bit more detail. So if you want to read about this a little bit more, check out that blog post. But yeah, that is it for me. So thanks again. And I check the chat here, see if there's any questions. Also, if you have any questions, feel free to, I guess, put your hand up or just unmute yourself and ask away. And thanks again to Madonna and Matt for letting me just talk at you here for an hour.
I see a few raised hands, but first I'm just going to say this was an amazing presentation, Zach. I mean, you've educated me in a lot, and I'm going to be using this in reference for the future when I start working on some of this, because I know we've not yet transitioned, but it will make sense when now I start transitioning, just coming back and just looking at the video and just going through it. And I see we have Anton raise his hand first. Do you have a question for Zach? Sure, go ahead and shoot.
Yeah, I do. Hello, everyone. Thanks for a great presentation and sharing your experience integrating Compose. I actually have two questions. The first one that I might have missed, but basically, how do you work when you have a complex hierarchy where you have a composable parent, then you have Android view, and then you have another composable rendering? How do you pass through the composition locals from the first one to the third one? Do you handle it by yourself, or it done by the framework, maybe some same mechanics as Vue tree owners?
Yeah, so it's a great question. And this was one of those things where we initially had to do it ourselves. But it all just works now. So actually, when you use that Android View composable, so are you familiar with like subcomposition at all?
Yeah.
Okay. So it takes the composition context and puts it, which is basically kind of like a handle to the current point in the composition, if you're not familiar with this. It takes that context and puts it in a tag on the view. Mm-hmm. And then when the Compose view side, the Compose view class, or abstract Compose view actually, will, similar to view tree owners, it'll look up the tree for a view that has a tag with a composition context in it. And it'll pull that out. And then if it finds one, it will pull it out and make the composition a subcomposition of it, which forwards all of the locals and make sure that all the recompositions and stuff happen. The Compose view class and abstract Compose view do have APIs where you can explicitly pass in a composition context as well. So you can like, override that default behavior and do more advanced stuff if you need to. But by default, if you're going back and forth just using those two basic things, it wires up the compositions for you automatically. It's one of those things. Yeah, it was like
It's pretty cool.
a bit of wiring that we had to do ourselves, and now it just works. And it's like you don't even think about it or know. Like if you don't know about subcompositions, you wouldn't even think about it, and it just work, and it'd be really cool. So yeah.
Awesome. And actually, if you might, I can ask another question. The transitions are a very important part of any navigation library. And you mentioned it briefly, but I'm not sure. So are transitions part of the workflow library itself as a core, or you implement transition more of like a user space implementation for each case?
Both, depending on what you want to do. So the workflow library provides something that we just call like a backstack rendering, which is basically just a list of other renderings, and a Viewfactory for that backstack thing. And all of the actual work you would typically think of as like navigation, most of that stuff just happens in the backstack Viewfactory. So it looks at when it gets a rendering, which is a list of screens, it compares it with the previous one and figures out like, was something pushed onto the backstack, or was it popped? Am I going forwards or backwards? It uses that to figure out if it should show like an enter animation or an exit animation, like how to coordinate those two things. It actually manages that animation. And it also handles state restoration. So it keeps a whole list of all of the states for all of the views in the backstack that aren't currently shown. It'll make sure that it restores those correctly, and it'll save you either between configuration changes or navigation events. So it is provided in the workflow library, but it's just another Viewfactory and rendering type. So if you want to build your own, there's nothing special about it. It's just we provide you a default one because it is a little bit of work, but it's just another Viewfactory, and there's no special secret APIs that we use for this. It's all just it's just using the same primitives. So you can build your own very easily on top of that. And we also do something for, like I said, dialogues. So we call it like a modal container, and you can basically, the way that we think about dialogues typically in workflow is like you have kind of predefined layers, and you can show the dialogues into those different slots. So and that rendering is just like there's like always like a kind of a base screen, and then there's like a list of things that might be shown on top of it. So and that composes really well with the backstack. So you could have like this modal thing, and then each of the child renderings inside the modal could be one of these backstack renderings. And you can have a backstack at each layer, and all of the transitions and all that stuff just like work, and you just have to like emit the right rendering types. And the rendering types are like basically just lists of data. I guess the one thing I didn't mention was like the actual stack itself. The workflows are like managing those. So like you have to produce this like list of screens that's your backstack. And how you produce that is like entirely up to the workflow. So in some cases, if you have a simple flow, like maybe like a setup wizard sort of thing, you have a fixed set of screens. And so you can just like create that list in a kind of a more fixed way. But if you want to actually like provide or have some logic that treats it like a stack and you're pushing and popping on the workflow side of things, you can do that if you want. You just, the actual view side of it with the transitions and all that stuff doesn't actually care how you manage that stack. So you can do it kind of more declaratively, or you can do it as like an actual traditional stack.
Yeah, thanks again. I will check out the source code definitely.
Yeah, we have docs on this too. I think if you go to the GitHub repo, there's like a link to the actual docs, and we talk about this a little bit more.
I also want to say thank you very much again. And I think it's just a question session. So if anybody wants to leave early, you're welcome. But if you want to stay around where Zach answers more questions, please feel free. And also very grateful for everybody that joined. Please make sure you join us on our next event. They always happen once in a month, which is super cool. But we also have the spaces that we do on Twitter, which is super awesome. Follow Mike, follow Matt, and Zach. I mean, Zach, that was great. Okay, Angel, it's your turn.
Oh.
Yeah, and just before you get started, to follow up with that, yeah, like if you want to ask more questions on Twitter, or like DM me, or I'm also on the call in Slack if you don't want to ask in front of the whole group. I check those all the time, so feel free to also hit me up there. Sorry, go ahead.
No, you're good, Zach. And thank you for taking the time, and also for Matt and for Madonna for even doing this. Honestly, this is my first time even hearing about workflow, and it sounds awesome. And I'm guessing I'm answering my own question, but is this something that I can use now in a project if I wanted to?
Yeah. There's actually there's a few companies outside of Square that are actually using it at the moment. And yeah, it's all open source, Apache 2 license on GitHub. We have tutorials and docs and stuff there that are improving all the time. Call out to Stephen Edwards, who's doing a lot of work with that. So kudos to him. Yeah, but it's all there, and yeah, it's all available. It's all public.
Okay, awesome. Thank you. This is really nice. Thank you. Yeah.
Yeah.
Good.
I was going to also say it's not just Kotlin Android. We also have the workflow library also exists for Swift in iOS, and it's written in Swift. And all the concepts are pretty much the same. Which was another thing that we wanted to do, so that our iOS and Android developers could write in their preferred languages and build things that were really tightly integrated with the native systems, but use the same architectural kind of shapes and terms. And there's actually like design docs at Square where someone's designed the same feature for both platforms with the same terms and wording and the same design, and using workflow concepts. But then it's like you write it in both Kotlin workflows and Swift workflows, but all the design and all that stuff kind of happens the same way. And I think we even had some like bug for bug replications at some point. So if you do iOS work, workflow is also available for that.
That's awesome. And I'm making the assumption that you, just like with the composable rendering, you have like a Swift UI rendering.
I don't know the answer to that off the top of my head. I know, so there's another kind of Swift UI like framework called Blueprint that's, I believe, open source that they are using. But I believe that Swift UI support is something that they would like to do. I see Kyle's in the chat. I don't know if you want to respond to that.
Let's see. I think there is an experimental Swift UI branch for workflow, but yeah, we mostly use Blueprint because we still support hella old versions of iOS. So Swift UI hasn't been a kind of key for us yet because we like literally can't use it in 90% of the apps that Square ships. So.
Okay. No worries. I was just curious because of the composable, but thank you. I appreciate that.
Again, it's the same kind of shape, and like the Blueprint is very similar to Swift UI API wise and kind of concept wise, and like they're all, we're all converging on the same things. So like adding Compose support to workflow was actually overall it was pretty easy. The hard part was like getting all the state management edge cases right, but the actual APIs and like the concepts and the way that maps, because everything's unidirectional data flow in workflow and in these things, like it just all works really well together. So
exactly. Okay. Yeah. No, thank you. That was awesome. I appreciate it. Really nice. Thank you, Kyle, too, by the way.
Kyle works on the design system team at Square. And Ray just also commented that as kind of a disclaimer, that if you're building a pure Compose app, workflow might be a little bit clunky because it's not clunky when you're using it in a traditional Android app so much, but Compose is so nice that it makes it look clunky. Cache built something called Molecule. It's another library that's basically a lot of the same kind of concepts as workflow, but using Compose. And it's like really nice. I haven't actually used it myself, but I've just kind of like looked at the docs and it was like, yeah, this is kind of what we kind of wanted to do with workflow, kind of eventually move it to Compose, and same kind of idea, but just it looks like much cleaner. So also check out like the Cache Molecule library, which is kind of the same idea.
Okay. No, thank you. I'm actually going to check that one out as well. And then a follow-up question with the design system. Is there anything also there available just like as an example, like, because that's actually pretty interesting.
Kyle, do you want to talk to that?
There is not. It is internal. It will at some point be external, but nope, nothing for now.
Okay, no problem. Thank you. Cool.
Kyle, if I can follow up on that real quick, are there like particular extra bits of layering we had to do to make our own theming, or are we able to just kind of follow common practices from the Compose team for how to write a theme?
I don't think we really had to do a lot of custom stuff, but also just I'm not an Android engineer. I don't play one on TV, so I do not know if we had uh, specifics. Yeah, I don't think we had to do a whole lot. I think we were basically able to just like slot in our existing kind of like theming and style sheets, and they just kind of like flow down the tree, and everything worked.
Yeah, I worked a little bit with the team on that. I don't know if there's anyone else from the team in the chat here. I don't think I see anyone. But like, so there was the little bit of the design system story I didn't talk about with Android was we had started building our own kind of declarative UI framework on top of Views just before Compose was announced. And so for that, we had built a theming thing using context wrappers, and which is typically how you do theming on Android. And so to make that work with Compose, we had to do some, we kind of like talked to the local composition local to get the stuff out of there. And then when we changed the theme, we like wrote that back into the local composition local. So it was all kind of hidden and just kind of worked, but it was a little bit of effort that we had to do to make that stuff work correctly. And like if we had started from scratch with Compose, we probably could have simplified that a lot and not gone through context and had to worry about the Android stuff. But we built it in such a way that you can use the theming seamlessly across both Android Views and Compose, which is kind of another cool thing. But like, there could be a whole nother talk on the design system work, so I'd love to see that at some point. But
yeah, me too. Thank you.
Great discussions. Tudor, you have a question for Zach?
Yeah, hey Zach, thanks for a great talk. I actually have like two questions that are kind of tying to each other and touch upon the molecule library you just mentioned. So I'm actually using workflow in a fully composed app, and I use it because I kind of like the structure it gives me. Like that's the main thing that drives me to use the library. The one thing that I wanted to ask is about performance. I mean, every time something changes, all the workflows render. How from Square's experience, I assume you guys have like huge trees of workflows. How does that work in a production app? And touching on that, would you see like moving the workflow runtime like to an actual composable, which is kind of similar to whatever a molecule does right now?
yeah,
Would that be like a performance improvement or something like that?
probably, yeah. So yeah, one thing that workflow does not do very intelligently right now is like skipping work. So like Dior mentioned, when we re-render the workflow tree to generate new renderings, we do the whole thing, which is like a ton of wasted work. And we have, I mean, like it's kind of been on the roadmap to optimize that. Like there's some pretty obvious like tree pruning we could do and just like not re-render most of the tree. But because workflows typically handle kind of like higher level stuff, and they're not, firing every frame, for example, it actually hasn't been too much of an issue performance-wise for most of the stuff that Square is using it for. There have been cases now where it's starting to come up as an issue, and so I believe there is kind of like a little bit more urgency to focus on some of this stuff. Ray could talk more to that. One thing that we have noticed is potentially a much easier kind of foot gun with views is if you're writing like view-based view factories, you need to make sure that you're that show rendering call, that it doesn't create views every time, and that you try to initialize as much stuff when you set things up, and then when you get new renderings, you just update as little as you can, and you might have to do your own diffing and comparison to make sure you don't set properties on views that are going to do a whole bunch of work every time you set a property. And so it's a little bit awkward. And then but that is a class of problems that goes away with Compose because it does that automatically, theory. But yeah, and Ray, if you wanted to speak more about some of the optimization work.
I don't have much to add to what you said.
Okay.
The reason that we get away with it is that, well, we did it that way because it's simpler, obviously. And while we are re-rendering the entire workflow tree anytime the state of any sub-state machine changes. It's just that view model that's being updated. So it's a bunch of structs, a bunch of data classes that are getting allocated, and that's about it. And it's not happening at animation speed; it's happening at user interaction speed. So a service call, a retrofit call response comes, and I update my state based on that, and then the view model gets rebuilt effectively. We do definitely rely on view code to be written smart, so that if I've got the foo widget and it's told, hey, the foo changed, we're assuming that the foo view is smart enough to notice that 90% of the text and images haven't changed, and so it's not going to throw away existing views and pull out new ones. But it is easy in non-compose code to screw this up, especially like if you're making like a naive recycler view or that kind of a thing. So there are problems that recur. There's optimizations that we'd like to make, but we've managed not to make them for a couple of years as we've scaled up to like 70% of our ridiculously big app using this stuff because on balance it works. And like Zach said, Compose makes that don't have stupid view code thing a lot easier just naturally.
Yeah, we kind of like built workflow imagining a future where something like Compose would be, that we'd be using it before it was even announced. Just because like, iOS already had their version Blueprint, and we were thinking about building something ourselves. So we kind of built it in a way that was like kind of awkward to use for views from the start. And it's about to get a lot easier with Compose. But yeah, which is hopefully, I don't know. It's caused a little bit of pain for us, but I think that like we built it for, kind of very forward thinking, hopefully. And I think that's about to pay off.
Got it. Have you guys considered using like the Compose, not Compose UI, the Compose runtime to basically like experiment with business logic, workflow as a composable business logic unit type of deal?
Yeah, I've done a little bit of playing around with that. Like after like using Compose for like 5 minutes, I was like, wow, we should definitely rewrite workflow to use this. Obviously a lot of work, but yeah, there's a lot of different shapes that could take, and I've played around with a few of them. I think there might be some branches still in the workflow repo that kind of have some samples. But then Cache came along and built Molecule, which is basically exactly what you're talking about. So I think from what I've read. So I would very much want to explore that as well before like trying to rewrite the workflow in this again, because they might have already just done the work for us. But it's really cool that like, everyone's kind of moving to the same kind of goal here. And like Molecule is the same thing where you're using Compose, the Compose runtime and Compose proper, but you're using it for business logic. And that separation, I think, is really is really effective. I think like it's easy to look at Compose and just be like, oh, this makes writing UIs really easy, and then kind of accidentally fall back into like building your entire app architecture around views essentially again. But keeping that separation of concerns between your view layer and your presenter layer or your business logic, whatever layer you want to call it, is really powerful. It's really good for testing and just modularization, and like, yeah, there's so many advantages to that. And you can do that, but also have all of the same nice unidirectional data flow concepts and reactivity and declarativeness and stuff on both layers, and still keep them separate. And I think that's like kind of a nice sweet spot.
Nice, Mutt. Your hands is raised up. You got a question?
Yeah, thanks, Zach, for all this stuff. I wanted to jump back into the Viewfactory and renderers. It seemed like those you could, plug and play with a bunch of different types of renderers. And
Oh, I lost your audio. Am I gone?
Yeah, me too. I think I can hear you.
can you hear me now?
Oh,
Yeah.
yeah, we can.
Okay. Yeah, I'm wondering about like the view renderers, if there's any way to provide like a test or debug renderer to validate what the data is coming to the view without needing to go through the UI phase.
I'm not sure I entirely understand what you're asking. One thing that I did not talk about that we also have is a special helper for Compose like preview functions. So you can just, because if you're writing, because most view factories will probably end up delegating to other view factories. And if so, to prevent you from having to like write the whole tree, we give you a special like preview function that you can call your view factory from, which will provide like fake view factories for your children and show what renderings you're giving them just as strings, as text in the UI. So you can write previews for your view factories really easily. But because view factories can be anything, you can always just write, like if you're writing tests, UI tests, you can just, which are also really easy to do in Compose. Once you start doing Compose, you can write unit tests for your UIs, which is really nice, and you should definitely do it. And if you're using view factories, you can just provide like a generic any view factory that just like supports any data type and like just doesn't do anything with itself, and just, you know, it's just empty. And so then you can just kind of ignore it. So it's really easy to like fake out parts of your UI. I don't know if that answers your question.
Yeah, it does. It was more like, can we supply like a test view factory that would be able to run these sort of unit tests on the UI without necessarily like being a UI test? So I think that does get to what I was talking about with the unit tests on composables.
Yeah, maybe. I mean, Compose, I think you can sometimes run tests with Roboelectric, like as unit tests and not instrumentation tests. I haven't done that myself, and I don't know if it's like, I think I know it's possible in some cases. It might not be super, it might be a little bit buggy. I'm not sure. It's Roboelectric. It's probably a little bit buggy. But you could theoretically write unit tests that way for your composable, for your view factories as well. But I'm not sure. Yeah, like we don't. Yeah, but otherwise I would just use like the regular compose test rule and all the regular compose testing stuff. And then you just provide a set content, and inside the set content, you just call your view factory's content method. And like it's a composable, you just call that, and there's no extra boilerplate.
Yeah, it sounds like I just need to explore the unit testing composables idea a bit more. I haven't done any of that yet, but that sounds great.
Yeah, we did a lot, like the navigation stuff, testing that. The Compose interaction with it was so nice. I would write the Compose integration test for like navigation first, and then I'd be like, okay, now I got to go to the view side and like got time to write like a fake activity so that I can set all this up. And like it was such a huge headache.
Wait, so if I'm getting this right, we won't do any like UI tests and Android tests. We'll just do unit tests for Compose.
You probably could. I guess I should have like clarified. So like typically I think when we talk about unit tests versus UI tests, we think like unit tests run on the host side on the JVM, and UI tests run on an emulator or a device as like instrumentation tests. But I think that's conflating like two different types of things. So like there's like unit tests versus integration tests, and there's like UI tests versus business logic tests, and like host side tests versus device tests. And so typically UI tests are integration tests because they're expensive to spin up and run and everything. So you don't want to run too many of them. So they're integration tests, and they run on a device, and they test the UI as well as maybe some business logic. And then unit tests test business logic. Typically they run on the host side, and they're like finer grain and actually test units. But Compose's testing library is so easy to use, and because they're just functions, composables are just functions. So you can actually write unit tests. If you think about a piece of UI as like a unit, you can write unit tests for individual like a button or something like that really easily. And you can run that. Probably you want to run that on a Android device, but you could use Roboelectric to run it on the host side. And you can just test your UI. But then you can also write integration tests and functional tests and all that stuff for your UI and everything else using that same testing infrastructure that would run on a device, or also maybe run on the host side if you're using Roboelectric. So yeah, so you can write, like, when I say you can write unit tests for your UI, you're probably running them on a device. So they're like, they're UI tests, but they're not larger kind of scale integration tests that test your UI and how it's all wired up and all that stuff. You're only testing one particular composable function. So it's like an actual unit test.
Wow, that's amazing.
Yeah, it's one of the coolest, one of my favorite things about Compose is like, it's really easy to just like have, so when we worked on the design system, we did this a lot. So like every component in the design system has a test file, and it's got like, 20 tests in it for all the different little state changes and stuff. Like, how does it look when like focused and, or whatever, and versus not, and how does that transition happen? And they're just short, like each test is like, 5 lines. It's really short and readable, and there's just like 20 of them, and there's like unit tests for your UI components, which is, you could do it with like Android views, but it would be a lot of work to set up, and you'd probably have more boilerplate, and it'd be a huge headache, and it's just so easy to do with Compose.
Love it. I love that. Again, thank you very much. I am so grateful that we had a great turnout, and then people stayed on to your talk. I mean,
yeah, thanks for coming, everyone, and listening. I hope that it was like useful, even though the workflow thing is kind of obscure, but I hope there was like some Compose stuff in there that people got out of it too.
it was very useful because you can tell based on the questions you got.
Yeah.
How engaging your talk was. So that was super great. So I'm going to stop recording because I think we're done, which is cool.